Right, final one then is parallel circuits. So parallel circuits is where the current has a choice. So on this one here, I've got, and it adds up. So on current, I have 4 amps of current flowing here. 2 amps choose to go that way, which means that if I've got 4 amps there, 2 have gone that way, it means that I've still got 2 amps flowing this way. Okay. Another amp chooses to go that way, which leaves 1 amp of current to go this way. So whatever the overall current is, you add up each branch and that gives you, that should match. So if I've got 4 amps here, that 4 amps is split between the branches. So my electrons have chosen to go this way, so I've got 1 amp. So at this point here, I've also got 1 amp. At this point here, I've got these electrons and these electrons. So at that point, I've got 2 amps. And if I'm here, at that point, I've got these electrons, and these electrons. So I've got all 4 amps again. Okay. So with current, it adds up. So you have a total, and then each branch will add up to that total. On a parallel circuit, if something broke here, so if the circuit broke there, this circuit still works. So with parallel, it's worth just remembering that if a circuit breaks, if it broke here, then the whole circuit would be out. But if it breaks there, that circuit still works. If it broke there, that circuit would still work. Okay. Right, potential difference then. It might have been the wording earlier that threw you, but potential difference is the same per branch. So this branch here has a potential difference of 12 volts. Okay. Which means that this branch here has to have a potential difference of 12 volts. This branch here has to have a potential difference of 12 volts. And this branch here has to have a potential difference of 12 volts. So each branch must add up to whatever the branch at the top is. If there's only one component, it's really easy. So there, if that whole branch has to be 12 volts, I've only got one component, that has to be 12 volts. Similarly down here, I've only got one component, so that also has to be 12 volts. This middle branch is slightly different. So that branch has to equal 12 volts, and I've already got one component that's 8 volts, so that means that this component must be 4 volts, because this branch must add up to 12, so 8 plus 4 is 12. So current adds up, potential difference is the same per branch, and then we look at resistance. So resistance is lower than the lowest. What that means, ow, sorry, I'm not starting again, you can just deal with that. What that means is that electrons or the current will flow around here and we'll go, oh, that branch is quite steep with resistance. I'm going to see what this one's like. That's also quite steep with resistance. I'm going to take this one. So most electrons will take this route. But it works it out as an average. There's calculations involved in this. There's time, there's distance, and there's speeds and all sorts. So with resistance, we say it's lower than the lowest. So the only exam questions I've seen previously are questions where they've got tick boxes for you to do. And it'll have, what would the resistance of this circuit be? And they'll have one option where it's added them all up, like it's a series circuit. They'll have one option where they pick 27, one option where they maybe have 2, and then one option where they have less than 2. So your answer is lower than the lowest. Okay, so it's because the average current route will take this one, and that's why.